Hi everyone, welcome to LearnNCode. As part of C Programming for Beginners course, in the last session, we have seen enumeration in C programming. In today's session, we are going to start the new topic, file handling in C. Before discussing the definition of file handling, let us have the differentiation between the primary storage and secondary storage. When the program or file can be retrieved from the secondary storage into primary storage, and when the program is going to store in the RAM or random access memory, or when the program is going to store in the secondary storage. You must know these differences. Without knowing these differences, you can't create a file. First, let us define a file. Actually, the definition of file can be given in two ways. You can give the high level definition or low level definition. When you go for the low level definition, a file can be defined as the physical abstraction of a secondary storage. Or we can say a sequence of bytes of secondary storage is called a file. Or in another definition, or you can say when you take high level definition, a file is nothing but the collection of related data. These are the differences, or we can say various definitions you can give for a file. Let us discuss first actually what actually a secondary storage is and how the abstraction of physical storage can be taken in the form of files that we will discuss. Now let us start the discussion of file handling by giving some introduction. We all know that the storage, or we can say the memory, is divided into two types. First one we are talking about is primary memory, or we can say the primary storage that we say as random access memory. And second one is we are talking about secondary memory, or we can say secondary storage. Under this secondary storage, mainly we are talking about hard disks, or we can say compact disks, pen drives, or we can also give an example of ROM, read-only memory, for the secondary storage. Now, important thing you should know here is at the time of writing C programs, already we have seen in the previous sessions how to write C programs and how to execute the program and how to save the program. See, while you are typing the C program on the editor without saving, what I'm saying here is without saving, then whatever the instructions that you are typing on the editor are stored in the random access memory. That is very, very important. Now, without saving, assume that you have executed the program and the program was successful and you have executed it and it is asking about the input and it is going to produce some output. Once you got input as well as output, and if you didn't save the program, that is temporarily stored in the random access memory. Now, once you switch from this C program, this P1, assume that into another program P2, then this program P1 is lost. Why? Because you have not saved the program so that it is not saved at somewhere. Now we will see the next scenario. Assume that you have written a C program. The name of the C program is prime.c. This is the program you have written. After writing this program, you have saved this program. Once saving is done, the program is stored in secondary memory, or we can say secondary storage. That means we are talking about hard disk. Okay. Now assume that we want to execute the same prime number program prime.c now itself. Then what happened here is the program that is stored in the secondary memory must brought into the random access memory. I can say the primary memory. The program that is stored in secondary memory, that is prime.c, is brought from the secondary memory into the primary memory, or we can say random access memory. Here we have the program prime.c. And this program is executed by the central processing unit. Now, at the time of execution, now the CPU is going to ask, or it is going to accept the input from the user. Now, assume that the input here is enter any number. This is the input we are giving. Assume that enter any number, and you have entered the input 7, and it has printed the output that the given number given number is prime. Here we are accepting, the system is accepting the input, at the same time it is producing the output. Okay, we have entered. Now assume that we have closed the program. Once the execution is completed, whenever you close the program, then automatically the program that is stored in the primary memory will be lost. At the same time, the input as well as the output data is also lost. This input and output data is also stored in the random access memory along with the program. Once the execution is completed, everything is lost, right? Now from the what do you say, random access memory. The problem here is the program is not there in the random access memory, but once you save the program, already we have saved this, that program is there in the secondary memory. Whatever the updates that you have done in the program prime.c will also be available in the secondary memory once you save the program. But the thing here is, what about the input as well as the output? The input and output data is stored only in random access memory, and whenever you close the program, the input and output data cannot be available. Now, how to store this kind of data permanently? For that, what you do is we need the concept of files to store the data permanently in secondary storage. That's the main intention of using files. In the modern era, there is no need of using file handling concept in C programming. You can use database management systems to handle the files. But as part of the topic in C programming, now we are talking about the file handling in C. So here clearly what I mean to say here is, so when you want to store the data, whether it may be input data or output data, or whenever you want to save the program permanently, that program must be saved in the secondary storage. That is very, very important. Now we go for the definition of the file. Now we will define a file. In two ways we can define a file. The first method to define a file is at low level. And second one, we're talking about a file also can be defined at high level. I will clearly explain what is mean by the low level definition and what is high level definition. High level definition can be given as it is a collection of related data. Collection of related data. For example, if you take student file, it is going to store the information, student name, rule number, marks. So that's why we are saying that it is the collection of related data. Here, the abstraction is at high level, not at low level. Now, when you talk about the low level, we are coming at the low level abstraction concept. That means, in this case, the definition of file can be given as it is a physical abstraction of secondary storage. Physical abstraction of secondary storage. What do you mean by abstraction? Just viewing, or the what do you say? We are not getting all the details, just we are taking whatever the details we want. So the physical abstraction of secondary storage, or we can say a file can be defined as a sequence of bytes. Sequence of bytes of secondary storage. You can give either this definition or this definition at low level. The definition of file in high level can be used rarely, but low level definitions you can give as a physical abstraction of secondary storage or a sequence of bytes of secondary storage. I will give what do you mean by the physical abstraction of a secondary storage, the overview of secondary memory in terms of physical abstraction. Let us take an example of hard disk. Here I am taking hard disk. That means it is secondary memory. This is a memory, permanent memory or hard disk, or we call it as secondary memory. We know that when you talk about the abstraction, assume that the memory is divided into four partitions, or assume that 4 parts. This is the C drive, and we can say this is the D drive, the E drive, and F drive. Initially, what we are going to do, The entire hard disk or secondary memory is divided into four parts. Or I can say, in the general example, assume that we have an almara which is going to contain how many shelves? Four shelves. This is the first shelf and second shelf and third one and fourth one. Here, general example, I'm taking almara as a secondary storage. Why? Because here we are going to store some items permanently. Similarly, here I'm taking hard disk, which is divided into four parts. Assume that C drive, D drive, E drive, F drive. Now, assume that in the drive C, again we are dividing into four parts. First part, second part, third part, and fourth part. And we call it as, assume that we have directory 1, directory 2, and directory 3, directory 4. Similarly, the D drive also divided into some other partitions. Again, we are assume that D1, D2, D3, D4. Again, it is divided into four parts. That means each and every sub-partition is divided into directories. Very, very important thing, directories. And these each and every directory is subdivided into, remember here, files. So what is mean by file now? File represents a area, small space, small space in the directory, where directory is the space in the drive, where it is the space in the hard disk. The low level, we are coming from hard disk to hard disk to drives level, from drives to directory levels, from directories to files level. That means we are coming down into the low level. So the low level abstraction of this hard disk or secondary storage is nothing but the file. This is very, very important definition. Or we can say in the directory we have files. A file is going to contain, assume that some bytes. How many bytes? Assume that 4 bytes. We can define that it is a sequence of 4 bytes. This is a very, very important definition of a file. After this, now we will see how to create a file, that we will see. Now we will discuss how to create a file. To create a file, the important thing you should know here is file pointer. How to create a file pointer? That means, so before going to create a file, you must understand the concept of the file pointer. As we discussed in the previous classes, for example, here we are taking it as integer star ptr1, and if you take float star ptr2, here ptr1, ptr2 are the pointers. So ptr1 is a pointer to integer type, and ptr2 is a pointer to a float type data member. But here, what is the purpose of using the file pointer? What is the type of the file pointer? Generally, here we are writing a star and some variable. Assume that I'm writing the variable as fp. fp in the sense file pointer. Now, what is the type of file pointer here? If you take ptr1, the type of the ptr1 is integer data type, and ptr2 is float. Means it is pointing to float, it is pointing to integer. Now, similarly, a file pointer is pointing to of type file. Very, very important thing, you should remember that to create a file pointer variable, star, any name you can give, then any name. Before the name, we mention the star, and before the star, you have to write capital letters FILE. You must mention this. FILE should be in only uppercase. What is mean by this FILE? Can I say it is the data type? No, it is not a data type. It's not user defined, it's not built-in data type. It is the data type of type structure. Very, very important thing. You should know that a file is the user defined data type called structure. and the structure of the file is defined in the header file stdio.h, which is already predefined in the header file stdio.h. What kind of contents are available in the file structure? That we will see that. The structure of the file, here I'm talking about a file structure, which is already defined in stdio.h. No need to define again, but here I will explain the internal contents of the file structure that is defined in the stdio.h. It is defined as the statement type definition, and here we are going to write the struct and opening brace, and the fields here are integer, file descriptor is one argument, and also there is a variable called size underscore t, size type variable. The parameter is size. These are the default parameters which are available in the structure. Now next, another size type variable is position, and also there is a variable called character star buffer, character pointer variable in closing brace. After writing the closing brace, we are writing in capital letters file. So here structure is the user defined data type. For this user-defined data type, we are going to give a new name, file, with the help of typedef statement. That's why we are calling file as a structure. And whenever you create a file pointer like this, file star fp, now the pointer fp is going to have the data members like this. One is file descriptor, and second one is the size, next one is the position, and next also the character pointer, which mention the buffer. So the internal details of this file descriptor and size, position means the file pointer position, that I will explain in the coming classes. So these are the very important four fields of the structured type file. Now, whenever we want to create a file, the first thing you have to do is you have to declare a pointer, a file pointer of type file, file. This is nothing but a structure. This is very important thing you should understand. With this, I'm going to close the session. In the next class, we will see what do you mean by the file handling and what are other operations that we are going to perform on the file, that we will see. Thank you very much for watching.